Good morning to all. I am Advir.
Good morning, sir.
Good morning, sir. Yes, sir.
Good morning, sir.
Okay. Today you all are going to learn normalization theory. This is the topic of third unit and very important topic from the GATE examination point of view as well as AKTU examination point of view and for your placement interview. Normalization theory is a very important topic. So first, what do we mean by normalization? Normalization is a formal, systematic and scientific process by which database designer can take decision of grouping attributes together in a relation or in a table. Means what type of the attributes we have to group together in a table. And in this way, we group the various attributes in different tables. But it is a scientific process, so there are various normal forms by which we decompose the complex relations into smaller, simpler and well-structured relations to reduce the redundancy and remove the various anomalies. Normalization is a scientific process, okay, by which we analyze the database and decompose that database into simpler, smaller and well-structured tables. Why we decompose that relation into simpler, smaller and well-structured relations? To reduce the redundancy and various anomalies like insertion anomalies, deletion anomalies and update anomalies which occur due to repetition of the information in a relation or which occur due to redundancy. So we have to reduce the redundancy. First, reduce the redundancy, and second one, remove anomalies. Anomalies means problem. The problem which occur due to redundancy. And there are three types of the anomalies in database: insertion anomalies, deletion anomalies, and third one is updation anomaly. Did you get it? Hello? Please
Yes,
let
sir.
me know.
Yes, sir.
Now, normalization theory is built around various normal forms. So normal form means a relation is in a particular normal form if relation satisfies a certain constants. And there are various constants for different normal forms and types of normal form: first normal form, second normal form, then third normal form, BCNF, and after that higher normal form, fourth normal form, fifth normal form, and then again sixth normal form, and still research is going on to develop higher normal form. This is endless process, and we refine the normal form. But till date, if you decompose your database up to third normal form, then your database design is very good. The industry generally decompose the relation up to the third normal form. Did you get it? Hello?
Yes, sir.
Now, there are various types of the dependencies, and these dependencies are the main reasons for anomalies. First one is functional dependencies. Second one is multi-value dependencies. and third one is joint dependencies. So for first two, BCNF generally based on this functional dependencies. First normal form, second normal form, third normal form, and BCNF. Are based on functional dependencies. And fourth normal form, actually we will remove multi-valued dependency. And joint dependencies we remove in fifth normal form. And all are in the third unit. And one by one, I will explain all the normal forms. So main aim in normalization, identify data dependencies in the schema which will cause update, insert and delete anomalies in the database based on those schemas. And these data dependencies are of three kinds: functional dependencies, multi-value dependencies and joint dependencies. The data dependencies which are causing anomalies are used to decompose the schemas in such a way that anomalies are avoided. For removing the anomalies, we decompose complex relations into simpler, smaller, and well-structured relations or tables. But we have a various constants through which we decompose the relations. Okay. Then actually our objective is to design good database, and fact principle of good design database, principle of good database design is one fact at one place, one fact at one place, not at multiple places. So if we keep one fact at one place, automatically redundancy will be reduced. And if we keep one fact at multiple places, then due to that there occurs various types of the anomalies: insertion, deletion and updation anomalies. So here we decide whether a particular relation is in good form, whether RDBMS follows the CODES rule. As you all already know, EF Code is a father of relational database management, and he gave 12 rules. And if you have good database design, then that database should follow all the 12 CODES rules. In the case that a relation R is not in the good form, then we decompose into a set of various smaller, simpler and well-structured relations. But each relation is in the good form. After decomposition, relation should be in the good form, not in bad form. And decomposition is a lossless joint decomposition. Suppose if we join all the smaller relations, then we get information. There should not be a loss of information. So decomposition is a lossless joint decomposition. Then only you can say that our database is good. Otherwise, your database is not good. And I have already explained normalization theory is based on functional dependency and multi-value dependencies. And third one is joint dependencies. So in fifth normal form, you all will study about joint dependencies. In fourth normal form, you will study about multi-value dependencies. And first, second, third, PCNF, you will study functional dependencies. Okay. Now, types of normalization. first normal form, second normal form, third normal form, and Bayes code normal form. BCNF is designed by two scientists, Bayes and EF Code. So it is called BCNF, and BCNF is a stronger form of third normal form. Normalization is a process that improves a database design by generating relations that are of higher form. If your database is in the third normal form, automatically it is in second normal form, and third normal form is higher normal form than second normal form. And if your table or relations are in third normal form, obvious your database is good comparison to second normal form. The objective of normalization to create relations where every dependency is on the key, the whole key, and nothing but the key. Here, all the non-key attributes should be dependent on the key, the whole key. They should not be dependent on the part of the candidate key. They should dependent on whole key and nothing but the key. If your non-key attributes is dependent on other non-key attributes, then there occurs problem. Keeping this in the view, we will decompose complex relations into simpler, smaller, and well-structured relations. Did you get it? Hello.
Yes, sir.
If you have any doubt, please ask the question. Now, in this slide, first normal form is considered the weakest normal form. All the tables are in first normal form. If you are creating the table, by default that table is in first normal form. If table is not in the first normal form, then that is called unnormalized relation, means that is not the relation. So by default in SQL, whenever you create any table, that table is considered the weakest form of the normal form, and that is in the first normal form. Second normal form is stronger than first normal form. Third normal form is stronger than second normal form. BCNF is considered the strongest normal form among all these normal form. But fourth normal form is stronger than BCNF, and fifth normal form is stronger than fourth normal form. Any relation that is in BCNF, automatically it is in third normal form. Any relation in third normal form, it is in second normal form. And if relation is in second normal form, it is also in first normal form. And see this diagram. If your relation is in BC, then this is also in third normal form. If your relation is in third normal form, it is in second normal form. And if your relation is in second normal form, it is in first normal form. And if your relation is not in the first normal form, means you have unnormalized relation. Unnormalized relation. That table is called unnormalized table. And if your relation is in fourth normal form, automatically it is in BCNF. And again, if your relation is fifth normal form, then it is in third normal form. And research is going on, and higher normal form researcher develop. Okay, means we apply some more constants on the relation, and that relation is called is in normal form, and that normal form satisfy apply a constants on relation. Did you get it? Hello.
Yes, sir.
Now, definition of first normal form. A relation or table is said to be in first normal form if all its attributes have only atomic values, or all the underlying domains contain atomic value or single valued. Multi-valued is not allowed in first normal form. Did you get it? Suppose we design a table like this. Design a table. Here, roll number, then name of the student and subjects. Suppose we write 1 Amit and subject is C, C++, DBMS, then OS, second 2 Sumit, and then again C, C++, DBMS, OS. So here this cell contains multiple values. This is not allowed in the table. A relation is said to be in first normal form if all underlying domains contain atomic value. But here multiple values. So this is not allowed in the table. Did you get it? So whatever table we create through SQL, that is by default is in first normal form. Very simple normal form. There is no need to explain this. Only one thing, he should contain a value which we cannot further divide. And if suppose we have a table, in table we have Amit Kumar Singh and only one column name, then we will consider that this is the atomic value. But better database, for good database design, we have to create 3 columns: first name, then middle name, and then last name. And then you can say that this table is in first normal form. But suppose we contain first name, second name and last name in a single column, then we will assume that this is the atomic value. So if you create table through SQL, by default that is in first normal form. Did you get the philosophy of first normal form? Hello, please respond to me.
Yes, sir.
Very good. Then see this table. Please let me know whether this table is in first normal form or not in first normal form. In this employee table, there are 3 columns: employee number, employee phone and employee degree. Then please let me know whether this employee table is in first normal form or not in first normal form. Please let me know. And why? Hello.
सर फर्स्ट एनएफ में नहीं है क्योंकि इसमें मल्टी वैल्यूड है एम्प्लॉयड इसमें मल्टी वैल्यूड है सर
In employee degree column, multiple value. Here 3 value: BA, BSc, PhD, and in this 2 values. Then how will convert this table into the first normal form? Please let me know. How will we convert this into the first normal form? There are several ways through which we can convert this table into the first normal form. One method is if we design table like this: employee number, then e-phone, and then qualification 1, qualification 1, qualification 2, then qualification 3. Suppose maximum degree is 5, then we create 5 column, and in this way we can store 333, then contact number, and here BA, then BSc, then PhD. In this way we can convert this unnormalized relation into normalized relation, and this relation satisfy the constants of first normal form. And what is the first normal form? A relation or table is said to be in first normal form if and only if all underlying domains contain atomic value. Did you get it? Hello? Please let me know.
Yes, sir.
And second method is, in this way we can also convert this unnormalized relation into normal relation. In this case, we are not increasing the number of the columns. 333, then this is the contact number and BA, and in second row again we store 333, then 233, 1231, and here BSc, and in this 333, 233, 1231, and PhD. In this way we can also convert this table into first normal form, but here there occurs redundancy, here repetition of the information, but our objective is to keep one fact at one place, but here we keep one fact at multiple place. But this is in the first normal form. This relation is in the first normal form. This relation is also in first normal form. But this is not the good way of converting this unnormalized relation into normalized relation. Did you get it? Hello.
Yes, sir.
Now please tell me, what is the another method for converting this first normal form, this unnormalized relation, into first normal form? Please let me know. Decomposition. We decompose this relation into a smaller relation, and that relation should be in first normal form. See here, we decompose this table two table. In one table we will keep employee number, employee phone, and in another table we will keep attributes employee number and employee degrees, and then one is master table and another is detail table, and through foreign key concepts we can establish relationship between master table and detail table. Did you get it? Hello. Now we decompose this relation into two tables. In one table we group employee number and contact number, and in second table employee number and employee degree. Now both are in first normal form. See here, we decompose relation into two tables. But still there is a redundancy. But suppose we have 40 attributes, then in that case, here we reduce the redundancy. We can't remove the redundancy. Why? Because at least one column should be common. And from that column, we establish relationship between two tables. Did you get it? Hello? Please let me know.
Yes, sir.
And
Yes.
if we'll join these two tables, then after join, we get the original table. And that process is called denormalization. Reverse process of normalization is called denormalization. So this decomposition is of type lossless decomposition. Suppose we join these smaller relations and we are not able to get the original table, then your decomposition is lossy decomposition, not lossless decomposition. And I will explain that concept later on. Did you get it? Hello?
Yes, sir.
Now second normal form. Definition of second normal form. A relation R is said to be in second normal form if and only if first condition it should be in first normal form. Second one, each non-key attribute of R can be determined only by full candidate key of R. This implies that there should be no partial FD in R. I have already explained that each dependency on the key, whole key, nothing but key. There should not be any dependency of the part of the candidate key. So there should not be any proper subset of the candidate key which determines the non-key attributes. If there exists partial FD in the relation, then your relation is not in the second normal form. So we decompose that table into a smaller table to remove this partial FD. And full FD can be determined only by the candidate key. Did you get it? Hello? What is the meaning of this thing? If you have any confusion, you may ask question. If in a relation there is no partial functional dependency, then you can say that table is in second normal form. If there is a partial functional dependency in the table, then that table is not in the second normal form. And for removing that partial FD, you have to decompose table into a smaller one. And in different way, we can define that all the non-key attributes is fully functional dependent on the candidate key. A relation is said to be in second normal form if and only if it is in first normal form, and all non-key attributes are fully functional dependent on candidate key. Now see here, if you have a table and in which there are various attributes A, B, C, D, E, and candidate key of this attribute is combination of A, B. Then A, B determines C attributes A, B determines D attributes, then suppose A determines E. So here the attribute which form the candidate key is called prime attributes. So since candidate key consists of attribute A and B, then A and B are called, we can say, prime attributes, and rest of the attributes are called non-prime attributes or non-key attributes. A and B are key attributes. Why? Because they form the candidate key, and these attributes are not involved in the formation of candidate key, so these attributes are called non-key attributes. So here, according to definition, all the non-key attributes are fully functional dependent on candidate key. So here C is fully functional dependent on candidate key. D is also fully functional dependent on candidate key. But E non-key attribute is dependent on a subset of candidate key. So this is the partial functional dependency. This is the partial functional dependency. And due to that, there occurs various anomalies, insertion anomalies, deletion anomalies, and updation anomalies. Then we have to remove this partial functional dependency. Since this partial functional dependency exists in this table, then this table, suppose name of this table is R, then you can say that R is not in second normal form. Why R is not in the second normal form? Because there exists partial functional dependency. There should not be any subset of this candidate key which determines E. Did you get it? Hello?
Yes, sir.
Please listen to me carefully. This is very important concept. Whatever I am saying, listen to me carefully. And if you have any doubt related to this concept, you can ask the question. Did you get it? Meaning of fully functional dependency, then partial functional dependency. Though I haven't explained functional dependencies. I have explained fully functional dependency and partial functional dependency, but still I have to explain functional dependency. Okay. Now see what is the meaning of functional dependency. Idea of functional dependency comes from the candidate key, concept of candidate key. So see here, suppose we have a table. Here we have A, B and C. Then here we write 1, B, then we write 1B, 2C, and then 3D. And again here we write C1, C1, then C2, and here C3. Okay. Now we write functional dependency like this. A determines B. When will you say A determines B? This is the table R. If any two tuple agree on their A values, they must be agree on their B values. If this constant satisfy on R, then only we can say that A determines B or B is determined by A. Did you get it? Hello? For any two tuple pair T1 and T2, if
Yes, sir.
T1 of A is equal to T2 of A, then this implies T1 of B equal to T2 of B. If this condition is not satisfied, then you can't say that A determines B. Did you get it?
Yes, sir.
Hello. Now tell me whether A determines B or A doesn't determine B. Seeing all the tuples in R.
Sir, A determines B and also C.
A determines B is true or not?
Sir, true.
See, if we take this two T1, T2, this is agree on A and agree on B also. Okay, but suppose we have this tuple like C to E, then what about A and B? Now tell, what about this functional dependency? Whether this functional dependency holds on R or not. Now if we take these two tuples, they agree on A value, but they not agree on their B value. Hello. So according to definition of functional dependency, this is not true. For any two tuple, this condition must hold on R. If T1 of A equal to T2 of A implies T1 of B equal to T2 of B. If any two tuple agrees on their A values, they must be agree on their B values. Did you get it? Then only you can say that A determines B. Hello.
Yes, sir.
So for this records, we can't say A determines B or B is dependent on A. Now tell about this, whether B determines C. For this set of tuples. Please
Yes,
let me
sir.
know.
Yes.
Yes,
No.
sir.
Why no? We will take only two tuple for these columns. So here repetition is in only B column, and here they agree on their B values, and here also agree on their C values, and no redundancy. Then for this set of the tuples we can say that B determines C. And tell me whether C determines B or not. Please let me know whether C determines B or not. Now from this side, again this is T1 and T2,
Yes, sir.
and they agree on their C values and also agree on their B values, and then there is no repetition, then you can say that C determines B. Did you get the concept of functional dependency? Hello.
Yes, sir.
So according to second normal form, all the non-key attributes are fully functional dependent on candidate key. There should not be any partial functional dependency. Okay, there should not be any proper subset of the candidate key which determines the non-key attributes. And what about key attributes? The attributes which form any candidate key is called prime attributes or key attributes. And the attributes which are not involved in the formation of candidate key is called non-key attributes or non-prime attributes. This terminology should be clear to all the students. Why? Because in definition of the normal form we will use these terminologies: non-key attributes, key attributes, then functional dependency. Okay. If you have any doubt, you may ask the question. Beneath Raj. Hello.
Yes, sir. Yes, sir.
Any doubt?
No, sir.
Hmm?
No, sir.
Very good. Now I'm going to conclude today's session. Today I explained the concept of normalization, then normal form, and after that different types of the normal form, and then what is the good design principle of database, then explained first normal form and second normal form. So normal is a formal scientific method for analyzing the complex relations and then decompose that complex relations or tables into the simpler, smaller and well structured relations. In normalization we reduce the redundancy and then remove the various anomalies like insertion anomalies, deletion anomalies and updation anomalies which occurs due to repetition of the informations. So if we reduce the repetition of the information, automatically that anomalies will be removed. Then first normal form. A relation is said to be in first normal form if and only if all underlying domains contain atomic value. And by default, all the tables which we create through SQL are in first normal and second normal form. A relation or table is said to be in second normal form if and only if first condition is it is in first normal form and second condition each non-key attribute of R can be determined only by full candidate keys, not part of the candidate key. This implies that there should be no partial functional dependency in R. Partial functional dependency refers to a situation when a non-key attribute A belongs to R can be determined by proper subset of candidate key of R. Full functional dependency can be determined only by the candidate key, nothing than candidate key. Did you get it? Now in this slide, definition is a relation is in second normal form if it is in first normal form and every non-key attribute is fully dependent on each candidate key. Second normal form and third normal form both involve the concepts of the key and non-key attribute. And what is the non-key attribute? The attributes which are not involved in the formation of any candidate key. There may be multiple candidate key, and those attributes are called non-key attributes, and the attributes which involve in the formation of any candidate key of R, then that attributes are called prime attributes or key attributes. So a key attribute is any attribute that is a part of candidate key. Any attribute that is not a key attribute is a non-key attributes. Relations that are not in the BCNF have data redundancies. A relation in the second normal form will not have any partial dependencies. So you can say that if table is in first normal form, obvious there are a lot of redundancy. If we decompose that first normal form into second normal form, then some redundancy, but still redundancy due to transitive dependency. Then again we decompose that relation into the third normal form, then redundancy due to transitive dependencies or anomalies due to transitive dependency occurs in second normal form, that will be removed in third normal form. And some redundancy still exists in third normal form due to dependency between two non-key attributes. Then we can remove that dependency in the BCNF. And in next lecture I will explain you a third normal form and BCNF. And with the help of the example, we will explain how we decompose relation into second normal form or up to third normal form or up to BCNF. And this concept is very important concept and very beautiful concept of database management system. Whenever you go for any placement interview, they will ask about this concept, normalization. Okay, now time
Thank
is
you,
over.
sir. Thank you, sir.
First, let
Thank
me
you, sir.
download the attendance and then leave the session. Okay.